positions. Internationally, Dr. Susilo was a military observer.
Recording in progress.
A peacekeeping mission in Georgia, and then he was placed as Engineer Education Center at military teacher for the Army Engineers, and later served as the commander of the Officers Education Unit. After serving as the Director of Planning and Operations at the Indonesian National Defense Forces Peacekeeping Center, he was appointed as the Indonesian Defense Attaché in the Hanoi, Vietnam, during the years of 2012 to 2015. From 2017 to 2019, he served as the head of Sub-Directorate of Doctrine at the Directorate of Strategic Policy, Directorate General of Defense Strategy in Indonesia. And recently, in 2020, he was promoted to Major General with the position of Chairman of the Institute for Research and Community Service. In academia, in addition to being a researcher and a lecturer at the Republic of Indonesia Defense University, he has served in various management positions at the university. Dr. Susilo previously served as the Dean of the Faculty of Defense Management and currently now serves as the Dean of the Faculty of Defense Technology. His research interests include peacekeeping, performance, and security systems in the Industry 4.0 era. So without further ado, please join me in welcoming Dr. Susilo Adi Buwantoro. Good afternoon, Dr. Susilo.
Good afternoon. Thank you very much, Dr. Panchahad Putra, for the time. Yep.
Good to see you again.
Good to see you.
For taking the time to speak to us today. You may begin your presentation anytime now. Thank you.
Thank you very much, Dr. Panchahadi. Thank you very much, Dr. Lintang Matahari. I would like to share my presentation today. Is it clear that my presentation already okay?
Perfect.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Thank you very much for the time for me. This afternoon, I would like to discuss and give this presentation about the roles of Internet of Military Things devices and computer for C5IS TER in military operations. And layout for my presentation this afternoon will be, first one is about the introduction, and then IoT operational requirement for military use in IOMT and IOBT also, and command control communications, computer, cyber intelligence, surveillance, target position, reconnaissance, or we can call that C5IS TER. Risk of IoT application in the military, challenge and technical limitation. Also, how I will also give and to discuss about IOMT use in C5IS TER and also in fire control system, mobile technology, and logistic management that will be consist of IOMT use in fleet monitoring and management, and also use in individual supplies. And later in the next slide, that will be how IoMT use in training and simulation and future military use of Internet of Things. And the last one, that will be the conclusions. You know, to discuss or to say about this, the roles of Internet of Military Things devices and computer for C5IS TER in military operation cannot be separated with the Industrial Revolution 4.0, also Internet of Things, Internet of Military Things, Internet of Battlefield Things, military operation in war, and also military operation other than war that in Indonesian language we call OMP and also OMSP. Sorry for that. For the Industrial Revolution, we know Industrial Revolution 4.0 we are facing at present occurs due to the emergence and implementation of new technology, such as like we discussed today, the Internet of Things, big data, cloud computing, and cognitive computing also, including machine learning, also like artificial intelligence that's already discussed in other presentations. The second one about Internet of Things, we know the existence of the Internet of Things plays a key role in the emergence of Industrial Revolution 4.0 also. Internet of Things describe physical objects that can be groups or such objects that are embedded with sensor processing ability, software, and other technology, and that connect and exchange data with other devices and system over the internet or other communication network without requiring human interaction or intervention. That's the important one for this Internet of Things. And talk about Internet of Military Things. We can say that the class of Internet of Things for military operations and application is known as the Internet of Military Things. Today, we know the deployment of IoT-related technologies by the military has primarily focused on application for command, control, communications, computers, intelligence, surveillance, and reconnaissance that like we call usually C4ISR. And then also we cannot also separate with, we have to discuss also Internet of Battlefield Things here. The Internet of Battlefield Thing is the terminology for IOMT, employing thousands of dynamically composed IOMT devices with sensors across the battlefield, exploiting autonomy and artificial intelligence to provide situational awareness and meet mission goals. And also, we know on the field, commanders are provided with comprehensive situational awareness through operation centers that receive data feeds from platform in the battlefield. So that's why to talk about this, we cannot also spread with this Internet of Battlefield Things. And like we are in Indonesia, we have military operation in war and also military operation other than war, because we know the main obligation of TNI include not only this, like a military operation in war, but also military operation other than war. And, you know, military operation other than war is the deployment of TNI forces to carry out military operations that are not in the context of war with other countries, but to carry out non-combat tasks, such as humanitarian tasks, tackling the consequence of disaster and for other national interests. We know there are various kinds of military operation other than war, like we face every day, like overcoming acts of terrorism, assisting local government tasks, and the third one is assisting the national police in the framework of the task of security and public order. Now I move to the next slide that we know in Internet of Things operational requirement for military in use in IOMT and IOBT. The military has a unique operational requirement for using IOMT and IOBT. Those requirements are related to the aspect of security, safety, robustness, interoperability, as well as bureaucratic and cultural barriers. Some of the important requirements can be mentioned as follows. Like we know, the deployment of one of the biggest constraints in a battlefield environment is power consumptions. IoT devices should be powered by batteries or solar power on the field and charged on the move from solar panels, truck, or even by motion while walking. In either case, they should like at least for the duration of the missions. And therefore, the devices and sensors need to be power efficient, and users have to use them appropriately. In mobility is another challenge for the IOMT and also IOBT implementation, because most of the services are expected to be delivered to user on the move. Service interruption can occur when the devices transfer data from one gateway to another. Therefore, devices and also sensors should support service continuity covering the whole battlefield on the area of operations. We talk about the security. Security is a parameter challenge that need to be addressed at every level of IOMT and IOBT. Several protection mechanisms and electronic protection measures features can be employed, namely low probability of interceptions, such as scrambling of the transmission data, low probability of detection, such as frequency hopping, and anti-jamming, such as IP security and IP tunneling protocols. Now we'll move to the next slide. We talk about command, controls, communication, computer, cyber intelligence, surveillance, target acquisition, reconnaissance. The main goal of C4ISR is to enhance synergies and interconnection among soldiers, technology and processes to provide commanders with accurate and timely information to gain decision advantage. It is achieved due to the C4ISR capability, which provide an advantage through situational awareness, knowledge of the enemy and environment, and also shortening the time between sensing and response. C5ISTR adds the role of cyber domains and target acquisition or tracking into the existing C4ISR capabilities to further enhance situational awareness and the overall capabilities. With the emerging roles of IOMT and IOBT, big data and data analytics can be employed to help determine in which direction combat unit can act quickly so that they are able to correctly put themselves in offensive and defensive position against an opponent. Therefore, through C5ISTR, the military will have superior network strength because of the amount of information that is stored, processed, and disseminated to many users in short time, thereby increasing human capacity to process information and make the right decision, especially for the commander in the field. We move to the next slide. We will discuss about the risk of Internet of Things application in the military. IoT devices and application in the military can also constitute significant security risk, especially regarding electronic and cyber warfare. As armed forces deploy in IoT devices and application, the number of entry points for cyber attackers will grow. Insider threats and user error are also cause for concern. So we have to be careful with this also because furthermore, most IoT technology rely on wireless communication via radio frequency and are therefore vulnerable to electronic warfare, including signal jamming and detection of true positions. Security risks are particularly prevalent in three areas that are vehicle safety, healthcare, and also supply chains. For example, hackers can potentially take over and steal vehicles. Vulnerability within the military healthcare system include the remote controlling of health and safety devices such as manipulating drug infusion pump dosage level, heart monitors, defibrillators, and ventilators. Military supply chains can also be compromised as IoT devices consist of component manufacture and assembly from locations around the world. Finally, many devices in the hand of military personnel can provide attackers with valuable data. For example, a smartphone camera might disclose information about the security of a military outpost. Now we talk about gaps and challenges that related to the application and implementation of Internet of Things. The military has deployed a range of IoT-related technology. However, there are still significant gaps in existing and planned systems. The military has a great number of sensors connected through an extensive network infrastructure, but only few systems contain a complete IoT package, from connected sensor to digital analytics and automatic responses. The military has also developed and deployed IoT-related technology in such an unintegrated way, making it difficult to generate synergies from different types of data. Other challenges can be mentioned as follows. Why the military has deployed a range of IoT-related technology? There are significant gaps and also challenge in existing plan system. That's about data collections is dependent on manual entry. Data integration system rely on manual data entry, particularly in the logistic area. Limited processing of existing data. Sensors and embedded devices collect massive amount of information, but the data are often never processed or analyzed. That's also, the next one is lack of automations. Automation is the heart of Internet of Things, but many Internet of Things related technology that have been deployed by the military lack automations. And the last one is fragmented IT architecture, where the largest problem across the military technology system is fragmentations. The military lacks of cohesive IT architecture that can support IoT that is efficient and defensible. Now we move to another slide that we talk about Internet of Military Things used in C5ISTER. C5ISTER system use millions of sensors deployed on a range of platforms to provide advanced situational awareness. Radar, video, infrared, or passive radio frequency detection data are gathered by surveillance satellite, airborne platform, UAV, ground station, and soldiers in the field. These data are delivered to an integration platform to provide a common operational picture, allowing for enhanced coordination and control. Military commanders are provided with comprehensive situational awareness through Central Operations Center, which receive data feed from platform. Lower levels, like a platoon or soldier, also have access to the data in the area. In this case, of combat pilots, they receive prioritized data feed integrated with data from their own sensor system. Security camera and sensor combined with sophisticated image analysis and pattern recognition software provide remote facility for monitoring and detecting security threat. In the case of marine and coastal surveillance, using different kinds of sensor integrated in planes, unmanned aerial vehicles, satellites, and ships, make it possible to control the maritime activities and traffic in the large area, keep track of fishing boats, and monitor environmental conditions. Now we move to and talk about the IoT used in fire control system. A fire control system is a number of components working together, usually consisting of a computer, an electromechanical detector, camera, radar, which is designed to assist a weapon system in targeting, tracking, and hitting its target. It performs the same task as human gunner firing a weapon, but much faster than much higher accuracy. Fire control systems are employed in various platforms such as warship, missiles, UAVs, and smart bombs. In fire control system, end-to-end deployment of different sensor network, including IOMT and IOBT, And digital analytics enable fully automated responses to real-time threats and deliver firepower with pinpoint precisions. Those systems are found in advanced platforms such as ICACSIS combat system or ballistic missile defense, Tomahawk land attack missiles, long endurance UCAV, and smart munition, etc. Now we talk about Internet of military thing used in mobile technology. Today, defense has an opportunity to take benefit from IoT by partnering with the private sector and adopting IoT technologies, particularly for tactical systems. This opportunity has led to the adoption of Internet of Things related technology in key areas. For example, like the US military has launched pilot program to implement mobile technology for its soldiers and also civilians. One example is the Net Warrior program, which equipped infantry units with modified Samsung Galaxy Note smartphone linked to the data-capable rifleman radio. Soldiers in the field can access a range of applications such as 3D maps, tracking of friendly forces, language translations, and also the profile of high-value targets. However, lack of connectivity, limited functionality, and pure user experience remain obstacle to the widespread deployment of this device. Nevertheless, the military is still struggling to equip its workforce with the basic function provided by COTES technologies, such as commercial smartphone or radio frequency identifications. Defense continues to drive innovation regarding advanced sensors, surveillance and reconnaissance drones, satellite communication system, and also control system. No doubt, in the future, the military shall further invest in mobile technologies and Internet of Things, especially to support tactical mobility for soldiers and their combat unit. In this slide, I will talk about Internet of Military Things used in logistic management because it is also important for the soldiers on the field. Logistic is an area where multiple low-level sensors are already being used in defense. Currently, their deployment remains constrained to benign environment with infrastructure and human involvement. The military has already deployed some Internet of Things technology in non-combat scenarios in order to improve back-end processes. For that purpose, to a limited degree, the military has deployed IoT technology for logistic management, which include joint logistic management to service branch using IoT device such as RFID to track shipments and also manage inventories between central logistic hubs. The military also use digital readers to monitor fuel level in tanks at distribution hubs. The system then use software analytics to adjust reading of fuel volume given environmental conditions such as temperature. Logistic data are fed into a back-end system with an interface that allows user to enter and track order and monitor the inventory of material. In this slide, we will talk about IoT used in fleet monitoring and management. Fleet monitoring can be representative by aircraft and ground vehicle fleets with onboard sensor that monitor performance and part status. For example, they track vehicle status and subsystem and indicate when resupplying low stock items such as fuel or oil is needed. Sensors will issue alert potentially reducing the risk and fatal failures. We aim to facilitate condition-based maintenance and on-demand ordering outpass, reduce maintenance staff, and decrease unanticipated failures of unnecessary part replacement. Although IoT deployment carries upfront costs, it can enable significant long-term saving by transforming business process across logistics. Defense has an opportunity to take advantage in the auto of industrial sectors and exploit performance data on existing data link to limit new security risks. By extension, IoT connected vehicle could also share information, for example, about available spare part. Real-time fleet management includes geolocation, status monitoring, speed and engine status, total engine hours, fuel efficiency, and weight and cargo sensors. Besides, when tracking shipment, the position and status of the containers can be monitored also to identify potential problem. I continue with the IoMT use in an individual supply where the deployment of RFID tags, sensors, and standardized barcodes allow for tracking individual supplies. IoT provides real-time supply chain visibility whenever it is being shipped, transferred, deployed, or consumed, and allows the military to order supplies on demand and simplify logistic management for operational unit. This smarter procurement of goods avoid delays caused by out of stock part of inventory carrying costs. Likewise, it can increase also accountability, enhance mission reliability, reduce losses, and theft of military equipment, and help with the time critically on the military maintenance. At the soldier level, tracking is useful in order to allow and also follow a proactive approach to logistic or to meet operational requirements. Soldier material such as water, food, batteries, bullets can be monitored with alerts and issued for necessary resupply. Now we discuss a little bit about IoMT, Internet of Military Things used in training and simulation. You know, information Internet of Things related to technology is also being used for military training and simulations. One of the IoT devices that can be used is a kind of wearable receivers to simulate live combat. For example, live combat training uses IoT cameras, motion sensors, and acoustic sensors to track soldiers during training exercise. Sending data to mobile devices for training, also for trainers who can coach soldiers in the real time, and producing edited video and basic statistics for troops to review after exercise. Another example is the multiple integrated laser engagement systems, which stimulate live infantry combat using blank cartridge and lasers. Similar to laser tag games popular with kids and teenagers, lasers mounted on weapons send code signal when the soldier fire a blank cartridge in simulations. If the sensor mounted on a soldier's clothing and equipment receive the laser signal, they register a hit, activating a beeping noise indicating the soldier has been killed. They also use connectivity, computer modeling, and neuroscience-based learning tools to provide a more comprehensive real-time training experience. Furthermore, the training can stimulate artillery fire, provide a battlefield effect simulator, which includes explosive devices like landmines, booby trap, and grenades. Now we talk a little bit about how we can imagine for the future military use of Internet of Things. In addition to the IoMT and IoBT technology discussed above, due to fast development of Internet of Military Things and also Internet of Battlefield Things, it can be easily predicted that the future soldiers shall wear the Internet of Things related device such as the following. For communication devices, in the form of a tactical radio equipped with voice and data transmitters, which allow wideband networking, and situational awareness gadget in the form of tactical mobile devices, which contain a variety of applications and also can share data between individual soldiers on the field. We can imagine it is very useful for the soldiers on the field. And also the situational awareness gadget in the form of laser designator rangefinder, which utilize laser spot imaging, celestial navigation, and laser rangefinder to generate a 3D map of the battlefield, and then network to the central command for enhanced communication and awareness. Health and safety equipment also in the form of helmet sensors, which measures acceleration and force for easy and early detection of traumatic brain injury. Health and safety equipment in the form of physiological status monitor, which measures, stores, and transmit vital signs to the soldiers and command centers. In short, military equipment currently in the development will provide enhanced situational awareness and communications to the soldiers of tomorrow and allow his or her health to be monitored in real time. Last but not least, for the Internet of, for the conclusion today, the Internet of Military Things, IoMT, is a class of Internet of Things for military operation and application. The Internet of Battlefield Things is the terminology for IoMT, employed 1,000 dynamically composed devices with sensors across the battlefield, exploiting autonomy and artificial intelligence to provide situational awareness and meet mission goals. We know in C4 ISR, command control, communication computer, intelligence surveillance, and reconnaissance capabilities take the benefit of Internet of Military Things to provide advantage through enhanced situational awareness, knowledge of the adversary and environment, and shortening the time between sensing and response. C5 ISTER adds the roles of cyber domain, target acquisition, tracking into the existing C4 ISR capabilities. There are risks, gaps, and challenges of Internet of Military Things application that should be addressed, including electronic and cyber warfare. There are clear also military benefits from the use of Internet of Military Things devices for the armed forces, ranging from C5 ISTER application, fire control system, mobile technology, logistic training, and simulations. Future Internet of Military Things use shall integrate much broader domains, such as communication, situational awareness, health, and safety. I think this is my presentation this evening. I hope that it is great for me if we can discuss and have a question from my presentation this afternoon. Thank you very much for the time.
Thank you. Thank you, Dr. Susilo, for the presentation. I'd like to proceed with the Q&A session. If any of the attendees here would like to ask some questions, please do so. You may raise your hand if you'd like to ask the question directly to Dr. Susilo, or you may use the Q&A feature here in Zoom. Perhaps while we're waiting for, Prof. Vishnu. All right, please, Prof. Vishnu.
Thank you, Mas Dr. Panca. Pak Dekan, Dr. Susilo, is very nice presentation. So, how about your opinion about the next battle? The next battle, I mean, we call technology battle. What is opinion about that? And is there any hybrid system? Or this is the first question about the technology hybrid and conventional in battlefield. What is your opinion? And in Indonesia, what Indonesia stages when maybe, for example, but we hope it is not really, because the battle is quite scratchy. What is your opinion about the Indonesia level, about the when, for example, we will go to the battlefield? And the second one, how about, for example, comparison among the South Asia, for example, ASEAN or Asia, about the technology in military in Indonesia? Okay, that's all. Pak Deka, Majen Dr. Susilo Adi. Thank you.
Thank you, Prof. Vishnu. Dr. Susilo, if you could please.
Yeah. Thank you very much, Prof. Vishnu, for the question, for nice questions. How is the next battle system in Indonesia? What level for this? That's the task for us. I mean, especially for the we are still thinking, and also, you know, for us, technology is very important, especially on the field. What level for this? I think now the member of TNI soldiers now start to be equipped with the technology things related to the equipment that they will use. That's why every planning in the year, especially for the soldiers, also for the equipment, like our Ministry of Defense already stated that it is very important for us to resupply and also to support the soldiers on the field, also the instrument and unit like the cavalry that you said, and also the other corps. It's very interest and also very important right now, because you know, the position of the technology that developed in outside area of military, especially in Indonesia Armed Forces, it's very, very high, and we have to adjust with this situation. And now TNI and also Ministry of Defense already try to get this technology directly into the equipment that we have on the field. Because like what I already explained before, we have the task for military war and also military other than war. I mean the task in the field. It is very important to support the program for TNN, also for defense right now. That's for the first question that raised by Prof. Vishnu, and then how the comparison, the technology that used in military in Indonesia. I think now we start to get used to it. Other, even I know the comparison between armed forces, especially in ASEAN countries. We still have a good quality, especially if there is like a rifle shooting range that range for the ASEAN countries. We always number on the top provision. It means that even we start to accomplish all the equipment by using the technology that now still developed outside. I think that the answer for the question from Prof. Wisnu. Thank you very much. Maybe I need to also, there is other things that from me. So.
Thank you. Thank you, Pak Dekan. Yeah, perfect.
Thank you. Yep. I do have a question. Two actually. I like the first one. There are many use cases, roles of IOMT as you described. I was just wondering, out of all those use cases, such as in C5, ISTAR, fire control, in even non-combat settings, are there any primary use cases, or where do we use IOMT primarily now in military?
Like thank you very much for the question, Dr. Panca Hadiputra. I think IOMT, it is now is very important, especially for the health sections. Education also in the military. Like I already mentioned before, it is to face with the era of COVID-19 right now. The support of military to support this, especially how we use this Internet of Things to connect with one part from one island to another island in Indonesia. You know, we have a lot of islands in Indonesia, almost more than 17,000 islands, and we have also a lot of unit around the area of Indonesia. I think the usage of Internet of Military Things is very important, especially how to connect the unit in central Jakarta, in central Java, from Jakarta to another city in Indonesia like Sumatra, Borneo, or other syllabus islands and other islands. It is very important. We can imagine that one time when the electricity is off and then Internet of Military thing cannot work properly, and then we back to manual again. We have to use the telephone or other telecommunication that not use electricity. It is also, we still have to think about this. If the scenario we lack of electricity in some islands, we need to think also for this. So, like related to the question that you raised, I think Internet of Military thing is very important right now, and we have to develop the capacity of military members to know more deeply about the technology, because we cannot. We have to adjust with the situation, also the improvement of technology. All the unit, all the military area in Indonesia have to increase the capability of personnel, especially also the equipment that will use the technology or Internet of Military things related to that task, and also the Internet of battlefield thing. This also we have to concern to that area, because we have to adjust with other countries outside Indonesia. That's I think the answer from me. Thank you very much, Dr. Panca.
Thank you, Pak Dekan. Yeah, I think it's very pertinent use cases in the health sector, right? Especially during this pandemic situation. And I think Prof. Wisnu also has research in telemedicine, right? I think that would be a potential or opportunity, perhaps, to deploy Internet of Military things, in the health sector. Yeah. And I would like to touch on the education aspect of it. You mentioned that we need to pay attention to the capability of the military personnel. Yeah. This is a highly technical solution that we develop, right? The IOM. Perhaps if you could share some of the initiatives or some of the programs that we understand that you're the Dean of the Faculty of Defense Technology. Perhaps you could share with us some of the education initiatives that could, address the issue of lack of capability, in the industry.
Okay, thank you very much for the question. How we also educate the students of Republic Indonesia Defense University. We try to open and connect and make a good coordination, a good relation with other university outside Republic Indonesia Defense University, also from the university from other countries. Like right now in Republic Indonesia Defense University, we have tried to cooperate with Granfield University and to get a good result from the education that will be given to the student all, at least that by having a good relation, a good cooperation with other university from outside Republic Indonesia Defense University, we can have a good quality that using also other technology that now still being developed around the world. And then at least we can get in touch with how the situation that can be solved together, because I think now one country cannot separate by itself. They have to have a good coordination, a good communication, also a good cooperation with other countries, even Republic Indonesia Defense University also. I think a lot of aspect that given to the students from the technology, even from the character, the content of the education that related to the technology that given inside the Indonesia Defense University. That's maybe Dr. Pancha.
Thank you, Dr. Susilo. I think it's good to hear that the university is open to collaboration with other institutions, not only in the military, right? I also have another question. Let's see. We still have time, right? Pak Lintang, you still have time?
Yes, we still have time until 3:30, I believe, yes.
Yeah, we have another 10 minutes. It's also interesting that you noted there are 4 challenges in your presentation that perhaps prohibit the potential of realizing the full benefits of IOMT. There are data collection that is manual, right?
Yep.
The automation and the fragmented infrastructure.
Yep.
Perhaps if you could please, which of these 4 challenges that should we address first? And also perhaps can you describe how do we go about addressing it? Which one should we prioritize out of these 4?
Okay, like what I already explained on my presentation, there are 4 data collection is dependent on manual entry, and limited processing on existing data, lack of automation, and fragmented IT architecture. I think to solve this problem and how we make the level of this to solve on the field, I think they have to be implemented at the same time. I think for data collection independent on manual entry, this is data integration system rely on manual data entry, particularly logistic area. It is important because that can support the operation on the field directly. If it is not good, I think the data will disturb the operation, the execution of the operations. Like if from your question, I think data collection is important, but we have also concentrate to the how limited processing of existing data. And it must be done, I think, at the same time. And also like optimizations, fragmented architecture, we have to concentrate that all in, I think, the same time. I mean, even if we have to prioritize which one, the first one, that's the question. I think we have to do that at the same time. And at least that we already look at which the problem on the field for this. Thank you.
Yeah, on case by case basis, right? That's good. I've seen a lot of movies, right? Using this IoT, right? And also you talk about the reconnaissance. I'm wondering if you could perhaps describe a typical reconnaissance. What are the technologies? I heard that you talk about the drones, right? What are the things that the military usually use to do this, to conduct reconnaissance operations?
Oh, okay. Reconnaissance, like the games that usually done by our children, I see. It's very interesting question. You know, if we look at the location of Indonesian islands, because we have more than 17 islands, especially for the part of islands that maybe right now it's very difficult to be in place directly to the exact location, except in Sumatra and Java, maybe Java Islands, we can directly go because a lot of roads or a lot of the way to go there to be used. But the implementation of drone is very important also, that connected to the operation on the field. Like say in Papua Islands or other Celebes Island or Borneo Islands, Kalimantan Islands, still a lot of places that it is difficult to get that place. But by having a good technology, like what you say before, drone, it is practice and also good equipment that can be used, especially how we can also look at and make reconnaissance, like on the border area between Indonesia and, say, the example, Indonesia and Malaysia, because we have already built the road along this border area, but by having this good drone to have a good technology, I think it can be good for the TNI unit, for the soldiers can directly implement it on the field by a good telecommunication and also a good technology equipment that can be used directly on the field, especially for the reconnaissance.
Thank you. Okay. I think we have another question from the attendees. There are two, actually. Yeah, the first one from Dr. Fira. Let me read out the question. Can you explain what the Indonesian military does to ensure all military equipments that we have are safe from all threats, considering that most of the military equipments we have are foreign production, produced by foreign countries? Yeah.
Okay. Thank you very much for the question. It is a very interesting question, that how can we make sure that all the equipment is safe from, if it will be used in our military units. Of course, there is a certain procedure that to be made or to be done to make this equipment that will be used in military unit. It is not directly when we a lot of things before we make an agreement to buy something from other countries. Of course, a lot of requirement to be implemented. What is the safety and the security for this equipment that will be used in the unit? A lot of procedure already made. So when this will be used, of course, that already have a lot of learning process, or I think from the unit that already have that task to look at the quality of that technology or this equipment that must be on safety and security if it is used for the military. I think that the answer.
Thank you. Thank you, Dean Susilo. One last question. What's your priority strategically in the next 5 years in terms of defense and management for countering IT security and data safety? Perhaps this one is related to the risk that you talk about, right? Regarding the IOMT.
Okay, thank you very much. What is the most priorities in the next 5 years in defense policy and management for countering IT security, data breach, and data safety? At least this activity also have a good answer to answer this question, because a lot of personnel that later on especially in defense policy, we have to make our students know what will be happen in the next 5 years, especially to counter IT security for this. So that's why we have to make a good cooperation with other university, other places, also to make the personnel or our officers, the members of Indonesian Armed Forces or other personnel, to have a good quality, to make the knowledge about the IT security or data breach, that we have to make this data safety can be processed safely, I think. Yeah.
Thank you. Thank you, Dr. Susilo. I think that would be the last question for this session. And thank you for an excellent presentation and insightful discussion on recent development of IOMT. We not only learn about the use cases and the roles of IOMT, but also the risks and challenges associated to them, and the future of IOMT by combining various things such as situational awareness, health, and safety. Right. By recognizing these use cases, risks, and challenges, we hope that the attendees who are interested in IOMT can now fully appreciate the capabilities of IOMT to fully exploit the potential of it. So thank you again. That was Major General Dr. Susilo Adipuwantoro, the Dean of the Faculty of Defense Technology, the Republic of Indonesia Defense University. Really appreciate your presentation. And before we end this session, let's take a picture while Pak Lintang, on behalf of the committee, will present a virtual certificate to you. Back to you, Pak Lintang.
Okay, thank you very much, Bapak Dr. Susilo and Bapak Dr. Panca. Maybe before we conclude this keynote session, we will take a photo together. Maybe for the participants who haven't turned on the camera, could you please turn on the camera so that we can take a picture together? Okay, now I will count to three. 1, 2, 3, smile. Okay, thank you very much. And then maybe the host can present the certificate of appreciation.
Thank you, Pak Dekan.
Yeah. Thank you very
Okay,
much, Dr.
thank you very
Panca.
much,
Thank you very
Bapak.
much, Pak Lintang Matahari. Yeah.
Thank you. You're welcome,
Also,
sir.
other participants. Thank you, Bu Edita, for the
Thank you
questions.
very much. Excellent, Pak.
Thank you very much.
Thank you very much. Yeah.
Okay, now we will move to the next keynote session. And we have been joined in this session by Bapak Profesor Heru Suhartanto. And also our moderator will be Bapak Dr. Reso Projo. Okay, maybe Bapak Dr. Reso Projo, the session is yours.
Thank you, Pak Lintang. Please, can I have my microphone check? Can you hear me?
Yes, I can hear you well, sir.
All right, thank you very much. Because I'm using an external microphone, so I do hope that everyone can hear me. Well, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera buat kita sekalian, and a very good late afternoon to all participants and audience. Currently, we are following with the keynote coming from Professor Heru Suhartanto. We have with us now Professor Heru Suhartanto, and before I give the microphone to Professor Suhartanto, please allow me to read a short CV of Professor Heru Suhartanto. Professor Heru Suhartanto gained his bachelor degree majoring in mathematics from the University of Indonesia in 1986, and then continuing to have his MSc degree from University of Toronto in Canada in 1990. And in 1998, he successfully received his PhD from University of Queensland in Australia, developing parallel numerical method for solving system on ordinary differential equation. His research interests include cloud-grid high-performance computing. Since 1986, he is working as a full-time academic staff for Pusat Ilmu Komputer or Pusikom University of Indonesia. He has contributed to the board of Fakultas Ilmu Komputer Pasilkom in 1993. Sometime in 1989, he was appointed as a teaching assistant at University of Toronto, and during 1998 to year 2000, he was also appointed as postdoctoral fellow at the University of Queensland. He was a referee member of Journal of Computational and Applied Mathematics, and then International Journal of Computer Mathematics, as well as Journal of Universal Computer Science in 2007. He was also a Vice Dean for General Affairs of Fasilkom University of Indonesia for a period of year 2000 until 2008. So since 2008, he was then appointed as permanent professor at the Fasilkom University of Indonesia. Professor Suhartanto, we have about an hour of time, which you can deliver your keynote and then provide, the audience and participants to basically interact with your speech. I fully giving you the opportunity and time, Professor Suhartanto. Silakan.
Okay, thank you very much. Can you hear my voice? Anybody?
Yes, sir. 5.5.
Yes, sir. I can hear you well.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, we would like to thank to the Allah Subhanahu wa Taala for the this session, for this opportunity, and for particularly for His bounty that we are currently in the health condition. And hopefully we are doing a better one until the next later. So I would like to thank to the organizer to invite me as the one of the keynote speaker. So I would like to share one of our works with some of our colleagues. So I would like to share my screen first. Let me see. Can you see this file? I would like to make it as a full screen mode. Can you read this file?
Yes, we can see it all.
Okay, basically this is the title of the talk will be residual network training with multiple GPU, and as you can see, that the residual network is one of the method or algorithm or technique in deep learning. We would like to train the methods, and then we particularly with some of data that we obtain from the Rumah Sakit Cipto Mangunkusumo. We got the image from the pathologies, and then we run the experiment with the multiple GPU. And then we have a colleague here. We can see that, you can see that Toto Haryanto was my PhD student. He graduated at about December 2002. And then another one is Professor Aniati. She's the professor in image classification and image processing. And then we also have Dr. Kusmardi. He's from the Cipto Mangunkusumo or the Faculty of Medicine, Universitas Indonesia. He works on the Department of Pathology. So that's why we work together with him in obtaining some data, and we try to process the data and try to help his department to identify or to classify cancer based on the pathologies images. So basically, the outline of my talk will be we would like to look at the motivation of using the high-performance computing in our works, and we would like to point some potential usage of the approach in other area. And then we would like to review a little bit on a deep learning architecture, and then we try to, and then we present our work, particularly on the role of multiple GPUs on residual network training. And then we describe the methodology that we have developed, and then we present and discuss our finding, and then we end up with our conclusion. Okay, you can see this in the trend number 1. You can see that look at the performance and the data, particularly in 1991 until 2010. Until 2010, the performance of classification was dominated by super-vector machine, supported by super machine. And when the data is increased, the SFM is outperform other classifier, such as neural network and some ensemble learning, such as random forest, and also a naive base. However, what will happen when the data stream keep on increasing? So you can see that. And the next one, you can see that in here, when the data sets and complexity are increased, the current classifier cannot be able to classify easily. Moreover, if the data is not separable, we have to design a robust classifier to differentiate the level of class. So a large or deep architecture is required for handling the problem. So we're going to look at the next one. This one, you can see that from this one, we can see from the chart in here that today deep learning, you can see that today's deep learning becomes state of the art and outperform even super-vector machine, which was the best one in the last few years. But in here, you can see that deep learning becomes the state of the art, and it even outperforms the super-vector machine. If we use a deeper network and larger data set, consequently, particularly when you have a huge amount of data, and then we need a high-performance computer to tackle the problem. So particularly if we have data that has to be processed at the same time, particularly if the way we compute the data is in the same time or parallel, that means we need to have a great number of processors. And then currently, GPU is one of the architecture, is one of the computer graphics that can be attached into our desktop, and then it can perform the high-performance computer nicely, particularly when the problem is dominated by data parallel computation. This is one of the potential of the deep learning in other area. You can see that it will have, or it will improve the performance in speech recognition and also in some recommender system, and then also the autonomous driving. As long as the problem related to like machine learning or deep learning, you can see that it can be improved by deep learning architecture, and also equip it with high performance computing. And also for real-time object recognition, you can see that in the real-time recognition, it needs some methods in relating and try to learn and try to identify an object. Particularly when the number of objects is too many, it is impossible to process it all by only using one or two processor. We also in robotic can see that also it needs some learning also problem, and then particularly when the robots try to identify and try to learn much data, so it will be very much helpful if they equip it with huge or a much better computing power. It's also in real-time language translation. You can see that particularly when the number of people are large when using the real-time language translation, in particularly currently you can see that it is very easily people can translate the language by using Google Translate, right? But, even it is also equipped with the sound or the voice of the speaker, and then it is impossible to process it without the help of the multiprocessor computer. Also, if you were talking about the health, particularly when the health data is represented in image or sometimes or even in a movie or a picture, so that also need to have classifier, and then when we do the classifier, that we need to do some learning, and then when we try to compare it, and then there is some data that has to be processed in parallel, so that we need to have what we call as the multiprocessor computer. But as you can see, look at in the previous discovery of machine learning, you can see that from the stories from 1950, the history of deep learning year to year starts from AI or artificial intelligence in 1950. And in the first of AI, rule-based and expert system is used. And commonly in the first AI is knowledge system. Okay, the first AI is knowledge system. And in 1980s, machine learning is introduced, and some classical machine learning such as naive Bayes, K nearest neighbors, and decision tree are displayed and are developed. And many people work on that method and also try to use it in several or others team. And then from 2010, you can see that deep learnings and some artificial breakthrough drive the AI. And currently, you can see that many people use deep learning in some of the problems related to the learning problem. And this is, you can see the architecture of deep learning network, one of the example. You can see that this is the difference between neural network and the deep learning network. You can see that on the left-hand side is the neural network, but on the right-hand side is with deep neural network. DNS is the extension of the NN. The deep learning neural network is the extension of the neural network. And commonly, the number of hidden layer in the NN is more than one. You can see that it is more than one, but on the left-hand side, it is only one. However, not only the number of layers in the DNN, but also how the feature extraction process occurred in the DNN. You can see in the next one that basically the output, you can see the output of the neural network and the neural network is similar. The output is similar, and the output of node in the layer denoted by Z, okay? Denoted by Z. Denoted by Z, we can see the Z is over here as the variable, which is the sum of multiplication among other input factor like X1, X2, and X3. And also the weights, it is also the input some weights, so W1, W2, and W3. And then this is how we compute the z, which depends on the variable of xi and also the weight of wi. And then the value of z become the input of various on the right hand side, become the various of activation function based on the layer. And for example, if we are in the classification layer, if you are the classifier, you can use softmax to classify the object. Next, we're going to look at the how to look at the deep learning and classical learning, and particularly and how to look at the workflow of each other. You can see that this slide describes the different workflow between classic machine learning and deep learning. And then from classical machine learning, in classical machine learning, we have to separate between feature extraction. We have to feature extraction, and then the model development. The feature extraction activities for any data can be text and also image, audio, or video, and must be conducted before the training step to develop the model. And then however, in deep learning, the feature extraction and the model development embedded in the sector. Okay, embedded in this in the sector. The pink one, you can see that the pink one over here, the pink one show the feature extraction, and the green color one, the green color one show is fully connected layer for training and produce the model. You can see in the next table that we have the history of deep learning. Currently, the new architecture is better than the previous one in terms of performance accuracy. You can see that it started from 1998, and then with LeanNet, and then also another one by Alex in 2012 until 2017. We have the DenseNet, which is produced by Guang and his colleague over here. And this is the architecture. We try to look at the architecture in more detail. You can see that we have LeanNet and AlexNet operator. We have the LeanNet and AlexNet. LeanNet is introduced by Yan Li Chun in 1998. And then this is the foundation of convolution zero network. This is the foundation of the CNN. LeanNet is simple architecture. With only two conventional layer and two polling or subsampling layer. For classification, LeanNet has two fully connected layer. Okay, as full connected layer, the architecture designed to classify minutes or digit number dataset. So it classify minutes dataset. So if we look at the output layer, it has 10 nodes. Okay, it has 10 nodes as the percentage of 1, 0, 1, 2 until 9. 1, 2 until 9. And in AlexNet, however, has a more complex architecture compared to LeanNet. Besides, the AlexNet used for complex classification tasks with about 1,000 class objects using image dataset. Sorry. Excuse me, I would like to repeat. AlexNet has more complex architecture compared to LeanNet. Besides, the AlexNet use more complex classification tasks with more than about 1,000 class objects using image net dataset. And the architecture is proposed by Henry Krzyzewski in 2012. Now we would like to look at more detail in deep learning architecture. In here we can see that there are two things that we have to look at: the GoogleNet and the convolutional pooling. And you can see that it is suggested by Strategy in 2014. The GoogleNet is a 22 deep convolutional network that is variant of the Inception network, which is a deep convolutional network developed by researcher at Google. So the GoogleNet architecture presented in image net large scale visual recognition challenge, which is produced by Redigi et al. In 2014. This problem is solved by computer vision tasks such as image classification and object detection, so that it can be used for image classification and object detection. And then founded how well it performed at the conclusion section of the article. And then today, Google Net is also used for other computer vision tasks, such as face detection and recognition and adversarial training, something like that. You can see that many people use some picture and then also some to recognize, and then they will input some of the picture and try to identify whose picture is it or so what is it. So in that case, Google use his own finding or his own work to classify or to find the solution and then to provide the solution to the user. And then the more data provided by the user, the more data can be learned by the deep learning method. And then that is one of the good thing of Google. They provide a free service to everyone, but everyone provide them with data. So this is one of the good strategy for the agent or for the unit or for agency to collect the data freely from user. And then the next one is the VGGNet. VGGNet is a convolutional network architecture proposed by Karen Simonian and also Andrew Simonson. They are from the University of Oxford in 2014. In this paper, mainly focus on the effect of convolutional network based on its accuracy. You can find the original paper, and the title of the original paper is very deep convolutional network for large-scale image recognition. So that means if we have very large-scale image to recognize it, we can use the VGGNet. This is the next one, the residual network, or we call it as in a short term as ResNet, as ResNet. And then ResNet, short for residual network, is a specific type of neural network that was introduced in 2015 by Keming. And then also had his friend in the paper Deep Residual Network Net Learning. In the paper Deep Residual Learning for image recognition. Again, another one. They use it for image recognition. The model itself were extremely susceptible for some reason. The first one, it has some award. Okay, it won the first place in the 2015 meeting classification competition with the top of 5 error rate. The error rate is only about 3.55%. So that's why they won the first place. They won the first place. And then for efficient training network with 100 layer and also with 1,000 layer. And the DenseNet itself, is a type of convolutional network that utilize dense connection between layers through dense block. Through dense block, where we connect all the layer. With matching feature map size directly with each other. To preserve the feeding forward nature, each layer obtains additional input from all preceding layer and pass on its own feature maps to all subsequent layer. Okay. And then to look at how it related to the GPU, and then you can see that deep learning usually it is a computational intensive. So there are many computation conducted inside the process, particularly on the convolutional activities and the pooling activities and optimization and augmentation. And also in the optimization, you can see there are some numerical method used in calculating some of the problem to solve optimization problem. So that means we need a good computing power in here. So of course, we have two types of computing power that we can rely on. This is the cluster architecture or GPU type of method. You can see that, but in cluster, it depends on how we connect one of another computer with network. So it depends on the speed of the connection of between the nodes. Okay, but in GPU we can put the GPU itself as the device into our desktop computer, and then even though we can put a GPU in one desktop, but currently it's possible to put more than one GPU into our desktop. But of course, we need to have a certain motherboard in order to able to attach the number of GPU inside our computer. So why is GPU is required? Why GPU is required? You can see that large data set, particularly when we have large data set, particularly processing the image with high resolution or image with the large number of data, usually requires deeper resources, particularly when the number of resolution is very very high. So the number of sub image is very very big. That means we need to have a great number of processor. Sorry, I would like to little bit. I have a problem with my throat, so I have to drink little bit every second because it's so dry. Okay, so again, why GPU requires? Because when we have a good number of data, particularly with the image with high resolution, we need a great number of processors. It is impossible to have huge number of processors in ordinary or desktop computer. One of the things that we can put the GPU inside our desktop because it's also the price is not that expensive. We can put the GPU in our suitable motherboard, and then but it require electricity, which is not it's not suitable if you have a good GPU in our home. So I would suggest those who have the GPU in our university or in our offices. And for deep learning electronic design, you can see that it is extension neural network, and then deep and complex data to produce more weights and neuron. And then consequently, the composition will occur because the concept of prediction of the neuron is multiplication factor, and you can see that the factor multiplication when we are talking about factor, and particularly when the factor is very very large or huge, you can see that there are many parallel process that can be processed at the same time by using different or its own processor. So in this one, maybe it is good to try to look at the GPU as one of the alternative resources. So in this one, we would like to show you one of our works when we use residual network, particularly residual net training. We use the image from histopathology and then try to classify cancer, particularly the cancer of colon, so as I mentioned before, we got the data from Cipto Mangunkusumo Hospital, and also some data which is available in internet. So in this one, the CNN is a deep learning architecture. So that has been widely implemented in the field of medical images such as histopathology. And one of the prominent deep learning feature is the residual network, or ResNet in short. The architecture is a characteristic that can identify input in denoted as X. You can see that denoted as X to the output layer. Because if the output layer is defined as fx, as the function of x in here, then the residual network output of the layer is denoted by fx plus x over here. So from this study, it is known that the use of ResNet was able to produce smaller error compared to the plain network. So ResNet also has advantage in avoiding Vanish gradient, when the level of selector is going deeper. So the gradient, you can see that this is one of the notation of the calculus. Okay, if we have a multi-variable function, and then we try to find its first derivative, and then we are ending up with a gradient, and then this notation is usually appear in the concept of optimization, and also in the concept of the large nonlinear problem. So the problem is here, the problem that we would like to solve is in here, yeah, the addition, particularly the addition of X input to the output layer will have impact on training process, especially the increasing of computing time and memory space. So that means we need to take particular action in here. So the trade-off between performance and accuracy and computing time. So they have sometimes when we try to have a good accuracy, so that means we need a great number of computation time. Today, GPU machine become the solution, one of the solution. But how to retouch it if we have more than one GPU in our machine? So having one GPU is simple, but what if we have more than one GPU in our machine? So that is how we solve it in our computing environment. Particularly, of course, if you look at currently in industry, many organization or many great researcher or many great organization has NVIDIA machine like the X1. Okay, it has about 8 GPU inside the machine. But if you look at the price, the cost of buying this machine is very huge, very expensive. Where in the last year maybe it's about 2 million rupiah, yeah, 2 million rupiah, which is unaffordable for most of us. But we can have a very efficient one. The one that we use in our computing environment, we just buy a desktop, and then we select a core, yeah, 32 core, and then we can put about 3 GPU in our machine. And the cost is about 150 million rupiah, yeah. Compared with 2 million, I think that this is a huge save amount of money. Yeah, this is money. The idea is how to get optimize performance in our computing environment. So why we look at the colon cancer today? You can see that in the colon cell today, the third highest number of cases after breast cancer and lung cancer is the colon cancer. You can see the colon cancer, and then potentially increase because the unhealthy diet, particularly when people has the habit of unhealthy diet, and then buy something to eat, anything they can find in the market without considering the health condition. It will affect the colon healthy, particularly when we met with our colleague from the medicine faculty. Usually the colon cancer was caused by the habit of people when they eat their food, particularly in the lunch or the dinner. So usually it will affect the colon cancer. You can see that this is the colon data set. The colon data set, you can see the colon data set. And then the colon data set we use in the study refer to the previous research that we have conducted. And then the good model was the good model must cover any previous data, the new data set. To cover any possibility of data set, we can reproduce using augmentation. And then this augmentation primarily refers to the image transformation. And then the objective of this step is to enrich the data set to avoid overfitting. When the model classify the new data set, there are some technique of augmentation that can be used, particularly vertical flip or horizontal, and image sharing and image rotation with various degree. So the degree can be from 0, 30, 45, and 135 degree. Okay. And then the data that the data preparation, here we have the data preparation. You can see that we got data with hematology and exhaustion from colorectal cancer, particularly from the common cancer data set. And then we get the data from this reference. It is hepatological image with 220 par by 220 par pixel, and then it has about more than 5,000 images. Okay. And then for training, we use about 3,600, and then for validation, we use it for about 1,200 to 1,700 for the validation. And then this is the ResNet Acetor design. So you can see that we use this one. This is in this Acetor. You can see that we have 3 GPU. Okay. We have the one of the GPU 1, GPU 2, and GPU 3. You can see that. And then we put the Acetor ResNet in here. We put it every Acetor in each of the GPU over here. To implement the parallelism on 3 GPU, we apply the module from multi-GPU model. And then you can see that if you look at the NVIDIA website, it has a Keras version framework that can be used for multi-GPU model. And in our X-Detector, it consists of sequencer block, including fully connected and 12 blocks residual. Okay, 12 block residual. And then there are 3 processes during the parallel training. First, we divide the model input. So when the training started, the input image in batch size will be distributed to dedicated GPU. Okay, and then we do the next one by using the copy and execute the model on the dedicated GPU. After the images are distributed, the model copy is executed on the dedicated GPU, and then after that, we use the concatenation on CPU into a big batch. Okay, so after the computation is done, then we have to collect it all in the CPU. So that means when we send the data to the GPU, we have one command to send the data into GPU, and then let it process, and then after that we have to collect it again, and then we try to concatenate all the data in CPU. And this step allows the image merge on CPU after the model executed on the dedicated GPU. This is, you can see that the environment that we use a GTX 1020. Yeah? We have 3 about that. You can see that it has 2,560 core. Okay? If we have 3, that means we have more than 2,000 core. Okay, 2,000 core. And then the memory itself, you can see that we are using only 8 gigabit memory. So you can see that. So this is very cheap environment. Okay, this is very cheap environment. We put it also with 3 GPU, but we can improve the architecture by using a much better desktop in here. But currently we have another type of GPU, which is GTX 2000 something, yeah, which is much better. We can put it in here also as well. And then we use the software like Keras and TensorFlow from NVIDIA to support our deep learning processes. We are using with 3 PCI Express buses for each GPU. We have 3 PCI Express in GPU. So it is not a very small desk, but it is something like a tower, because you can see that it has 3 PCI Express. Also, we have to have a good cooling environment in our computer in here. So we do not buy the computer ready, but we have to buy the spare part, and then we ask our customer, we ask our friends to build it. We only need to buy. We specify the spec of our computer, and then we ask them to build it into a ready to use computer. We can easily to replace the GPU. So if we have a much better GPU, you can put it here. Especially if we have a good one which has more than core. With a great number of core, we can put it here. We can replace it in here. You can see this is the model evaluation. It is the model evaluation. Let me see. it has a loss function. It is one of the usually performed evaluation which is commonly used by people in deep learning, and also we use the speed up, okay, from the sequential training time and then divided by the parallel training time. Hopefully, we will have a great number of speed up, and then we look at this accuracy, which is also commonly used in the result of the deep learning process. This is what we got. This is the spec of our CUDA. You can see that the core is like that one, and the memory of each of the GPU is about 10,000 giga. Okay, we design the 3 scan row by training several number of bits. So that means we have about 8 and 16, 24, 32 bit size, and then we try to monitor the processor and try to monitor the memory used by the processor. Okay, this is the, you can see that this is the result of residual training. So you can see that the RLS success on 3 GPU, and in the visualization of GPU, you can see that utilization for its epoch in presentation. You can see that it's about 50% over here. This is the BGPU one over here, and then over that see the GPU second one. Okay, and then you can see this is almost the same. We put it together. Okay, fusion of GPU process utilization for each epoch in presentation. In general, GPU 3 utilization is relatively greater than GPU 1 and 2. You can see that the gray one, which is representing the GPU number 3, it looks like is much better than the other GPU. Okay. You can see the average GPU utilization. Let me go back again in here. This chart visually the use of GPU process during the training using RSN, using ResNet, and then the utilization is captured for each epoch, and then we calculate the average of GPU processor utilization. We try to look at the utilization. In the top left in here, the visualization for 3 GPU when the batch size is the batch size is 8. Okay. And the number batch size is too small so that the GPU with GPU 1, 2, and 3 is not utilized very well. It's not utilized very well. During the training, we save the GPU utilization. But on down right over here, something like this one, when the batch size each GPU is used for while training, it can be seen from the color of the graph. You can see that when the batch size is try to increase, okay, you can see that it's much better. If you look at this one, compare with this one, so the utilization is almost the same for the whole one. Okay, you can see on the left, the top left one is not stable. Okay, but on the right down the down right, it is almost similar, the 3 of them. The next one, we like to look at the picture after the training. After the training is finished, we calculate the average of utilization for each GPU, GPU 1, GPU 2, GPU 3 for each batch size. This is the batch size over this, the batch size for 8, 16, 12, and 32. And the utilization will significantly appear, and we use the more batch size. You can see if you use more batch size, you can see the utilization increasing. Utilization increasing. If we use more batch size, that means you look at the utilization is increasing. Utilization increasing. You can see that GPU 3, which is you can see that one is still dominated over there. You can see it's still dominated. I'm not sure. We have to investigate more because each of the GPU it has the same. It has the same spec. Yeah, it has the same spec. It is very interesting if you try to conduct more experiment to find that why this one is much better than the others. Much better than the others. So you can see that running GPU with a great length of time is very consumptive, particularly when the running is very long. And it will be a disaster when we run the program and then the electricity is being cut off. Even in university, you can see that sometimes we have electricity is cut off. That means it will be a disaster for us, particularly when we are about to finish our experiment. So this one, the next one is the memory utilization, and then the training using ResNet need more GPU memory. You can see on the top left, this is the top left. Memory consumption of the GPU is not significant. Even in this scenario, 8-bit size, in this scenario, we are using 8-bit size. The RSN can conduct it using single GPU only. But on the right-hand side of this one, down right, more consumption of the GPU is distributed to all GPU machine. You can see that. You can see that one. This is not stable. The one is much more stable. You can see this one. Try to compute in detail for each of the GPU. You can see that the GPU utilization is not visible when the base size is too small. You can see that we do not have a great number of percentage over there, but we try to increase it, the base size. You can see that you can use much more memory. Okay, you can memory. The larger the base size and the more visible the utilization. Okay, so the average value of the utilization is, you can see that below over here. You can see that GPU 3 is not, again show much better than the other GPU. So in this experiment, we would like to inform you that we are the only user in our computer. No other people using our computer. You can imagine if many people using our computer, that means the performance might not like this. The performance might not like this one. The performance might not like this one. Okay. The next one, we try to look at the average training time per epoch in second. You can see that the training with 24 and 32 of bit size, it cannot be able or run on single GPU. It cannot run on CPU. You can see that we compare with the computer with 16 core over here. Okay. This is a single GPU over here. We run the problem with single GPU, and then we try to run it with multiple GPU, and also we try run it with a CPU with 16 core, and then we try to look at the speed up. Okay, look at the speed up. You can see the single GPU is not that different, but a multiple GPU is still much faster. Still much faster. But in single GPU, it cannot solve the problem. You can see that it is out of memory. Okay. So especially when we are using 24 and 32 bit size, again, that means it requires more memory. So that's why using multiple GPU is much better. So that means it can accommodate more data in the processing. If you compare this CPU processor and compare with MLT, you have about this kind of speed up. You can see that. So that means we cannot rely on desktop only, but we have to equip it with GPU. That means you can see that it's about 100 times much better than that one. Okay, much better. And then we try to look at the more memory consumption in detail. In here, this table is written detail of the memory consumption of GPU during the training using RSN. Okay. You can see that this is the memory consumption. Okay, then you can see that, for example, if you look at the previous one, I would like to say that in GTX 100, it has a 8 gigabyte size for each GPU. Okay, you can see that it can almost use all of the memory of the GPU. It can almost use. You can say it is 7.64 gigabytes, which is almost 8, which is okay. So even we are using 32 bits, we can still do the processing. So according to the table, we need about 119 and then about 120 megabyte GPU memory per image in the forward step. Okay, so that means if we are using more great number of images, that means we have to use another GPU which has a better size of GPU, particularly on its memory. And the next one, the ResNet performance. We try to look at the ResNet performance itself. You can see that As the performance evaluation, we try to look at the loss and accuracy. There are two metric used. On the scanner we are using a scanner of 8, 16, 24, and 32 best size again. Using the best size, and then the top left you can see that this value, this value is the calculated based on the loss of function. We are using loss of function. Now, training loss value that compare error classification on the training data set, and the value itself will be converted to 0. Okay, it will convert to 0 because using the training data, it is normal that the value is commonly better than the validation loss. And the top rock, like this one, the top right, validation loss, we are using the validation loss. This value also calculated based on the loss function using the validation data set. So the value is not good as training loss value. The validation loss value is the representative of performance of our model. And down left edition, we are using the train ACE. This graph is the accuracy of model based on the training data. The value the value of train ACE, train ACE, which is the train accuracy, will convert to 1 in integer. So this will convert to 1. And then down the next one will be down left, the validation accuracy, the validation use generation of our model. If the value is converted to 1, if the value convert to 1, we can say that the model is good. Okay, it convert to 1, the model is said to be a good one. But in our case, we still inconsistent accuracy. Sometimes we can approach until to 1, but sometimes we do not approach to 1. And then we have to turning the other parameter of residual. That means we have to find a good parameter of the residual training in order to have a good accuracy. So in the conclusion, we can see that all 3 GPU machines have contributed to the computational process and data allocation. Particularly, we cannot rely only on 1 GPU only. Okay? More than that, using multi-GPU give us a question to improve our model. And according to the validation accuracy, our model is still to be improved. We need to improve it further to obtain a stability of confidence values. And understanding GPU utilization become important to consider the trade-off between the model performance and the computation time. So that means we can find another model, but sometimes it can also affect the computation time during the training process and also on the accuracy. It is not still perfect, but we need to further work on this area. And then we have actually we have published this talk in another meeting, and then we have also submitted. We also have delivered the talk in other meeting also. And then we got the funding from the Ministry of Education. Thank you very much. So I would like to stop my sharing.
Thank you, Professor Suhartono. It's very great keynote that you provide today. Unfortunately, we have only about less than 5 minutes of time for anyone that would like to raise some queries, questions, or perhaps some information to be discussed further. I allow you to basically raise your hand or use the question and answer or chat system or function that we have within our Zoom system. Okay, if there is none, I actually would love to have Professor Simon C. sitting among us, Professor Suhartono, because he is very compatible to what you have.
Yeah.
I think he'll be able to deliver some good question. However, please forgive my ignorance on this matter. But there is, a question that I would like to raise to you. You are using a similar GPU, in this case, the performance. What happened if you use a different type of GPUs? I actually a little bit familiar with the transputer type of computing in the late 80s, because I was basically doing a similar thing. But at that time, it was still, what you call a classical machine learning time, which actually, you have to teach the system and provide some limitation for the system to understand. And we have problem while we are trying to link one to another. At that time, it's not the GPU but the CPU.
Okay.
So in this matter, does flow of data while using a different quality of performance of GPU will then provide you to have a good performance because there is a bottlenecking in data flow?
Okay. Actually, we also worked on machine learning problem, but few years ago. I mean, in the beginning of 2000, when the GPU is not hurt yet. Okay, the GPU not hurt yet. At that moment, we try to classify and try to identify the smell, okay, or the smoke. Okay, we work with our master student. Even though we can speed up the process of learning, but the speed up is not that good. Okay, we at that time we do not have a good computer. We try to use a cluster. That one we develop our computing environment of a cluster, and also it depends on how we have the the network itself. Okay, currently we have a very good network technology in order to speed up the process. But at that time, also we do not have a very satisfaction result, because if you can see that at that time we only have about 4 or 8 or 8 nodes. That means we are using 4 or 8 computer at that time in order to support our experiment. So we cannot have more than 8 computer at that time. So that's one. So when we have when we know that currently we have the GPU, so and we know that particularly when the data parallel programming data parallel problem is occurring, so that's been it is it is much better to consider GPU one of the alternative. You can see that one of parallel programming one of the parallel processing can be put it in one GPU. Okay, if we have more than one GPU, that means in our case we have 3 GPU. That means the 3 jobs can be submitted each of this GPU. So it means for discrete number of data can be processed nicely in each of the GPU. That means the speed up maybe can be much more if we compare with if we do it in cluster. Especially when we have the GPU itself, since it is residing in our desktop, I think it is the transferring data is not that matter if we comparing with cluster. I think. But again, we still
Thank you, Professor.
We need to improve our.
Thank you, Professor. Yeah, thank you. I'm still inviting anyone that would like to raise some further questions. If there is not, actually, there is one other question, Professor Suartanto.
Yeah.
Just curiosity on graphical noise filtering. I mean, I see that you are using MRI or CT scan data. What if you are using ordinary X-ray data? Would you have any difficulties doing the noise filtering on the picture?
We haven't used that data yet, but I think it is a great chance to look at and try to experiment with data. I mean, especially when we start our experiment, we have to communicate intensively with the hospital, because we have to clarify. We have to some rule to the hospital that the data cannot be published to other people, and it can be used only for this research. I think we have to consider it very seriously. But if we have more data, it will be much better to find what will the effect of our experiment, our method in solving the problem.
Thank you, Professor Heru Suartanto. I think I'm afraid because due of the time that we are very limited. So I would like to return and surrender back this time and space to Mas Lintang Hasani. I think we need to provide Professor Heru Suartanto with a certificate of appreciation. The time is yours, Pak Lintang. Silakan.
Okay, thank you very much, Bapak Prof. Heru Suartanto and Bapak Dr. Yono for this keynote session. Maybe the host, could you please present the certificate of appreciation for Prof. Heru? Okay, here is the certificate. Thank you very much,
Okay, thank you very much.
Bapak Prof. Heru. And thank you very much also, Bapak Dr. Yono, for this interesting keynote session.
Thank you.
Okay, thank you
You're
very
welcome.
much.
You're welcome.
Okay. Okay, everyone. We will move to the next keynote session, which will be delivered by two keynote speakers, actually, two keynote speakers as a team. The first it will be Bapak Dr. Ahmad Gamal and Bapak Dr. Aryo Wisodo. And this session will be moderated by Bapak Prof. Wisnu. Maybe Bapak Prof. Wisnu, please, the session is yours.
Thank you, Mas Moderator, Mas Lintang. Okay, for this session, we have two outstanding plenary speakers who will deliver the interesting presentation. First one is Dr. Ahmad Gamal, and the second one is Dr. Aryo Yudo Husodo. Dr. Ahmad Gamal, maybe he will send a video. And how about the Dr. Aryo Yudo Husodo? Are you there, Dr. Aryo?
Yes. Good morning, Mr. Wisnu.
Okay, thank you.
Yeah,
Okay, I will read the profile of the speaker. Dr. Ahmad Gamal received PhD in 2016 from the Illinois University, USA, and also his expertise has been nationally recognized through his policy-driven work at the Directorate of Poverty Alleviation, Indonesia Ministry of Development Planning, or we call the Bappenas. And Dr. Gamal currently serves an assistant professor at the master program of Urban and Regional Planning, Department of Architecture, Universitas Indonesia. He also serves as the advisory for the Smart City Center and director of Innovation and Science Technopark at Universitas Indonesia. Okay. Meanwhile, Dr. Aryo Yudo Husodo, he obtained doctoral degree in 2021 recently, and during his study, he already published more than 4 or 5 journal quartile 1 published in IEEE, ICACSIS, and so on. Now, Dr. Aryo Yudo Husodo is a lecturer from Universitas Mataram. Okay, first we will make a video about the Dr. Ahmad Gamal. How about the committee is already? Okay, we can start. The sound is maybe please share screen with the sound.
And Information Systems held in. Good afternoon. Welcome to the 2021 International Conference on Advanced Computer Science and Information Systems, held in conjunction with the 2021 International Workshop on Big Data and Information Security. My name is Ahmad Gamal. I'm currently the Director of Innovation and Science Technopark here at Universitas Indonesia, and I'm going to present to you the progress of Universitas Indonesia academics research on artificial intelligence. Particularly, what I'm going to give a brief illustration about are the use cases of artificial intelligence in medical research and urban planning or urban management research. So let me share my screen. I hope that's pretty clear to you. And so today I'm going to talk about Universitas Indonesia's progress of artificial intelligence research. This is not all about my research, but the research of my colleagues here back at Universitas Indonesia. Some of the use cases in health research are predominantly in Universitas Indonesia. One of the most important use cases of artificial intelligence is how researchers from the Faculty of Information Science and Faculty of Medicine works together to identify heartbeat and classify heartbeats. So, for example, they produced eCardio, which is an integrated system that helps people to examine their cardiovascular health without having to actually physically see a doctor. This is especially useful in a situation like Indonesia, where sometimes hospital access is not always easy for people in rural areas. So the system utilizes sensors to measure a person's heartbeat and then will visualize and store the heartbeat data in an Android-based smartphone. And then the system, using some artificial intelligence, could also provide automatic classification of the person's cardiovascular health. In addition to that, the system also sends that person's cardiovascular data to a doctor and to a nurse. And through a method for electrocardiography signal, the data is then compressed and then transmitted via cellular transmission systems. And it's very interesting because now, with the help of very simple applications developed for Android-based smartphones, eCardio can be used by a layman's person, someone who doesn't really understand medical practices, can basically use this to monitor his or her own heartbeat and then store the data in his or her smartphone and send that data to the doctor and gets a recommendation. And this system is also applied within the big data framework. So the patient can use the electrocardiography sensor and then store the data on his or her smartphone. A cardiologist can basically evaluate that data through his own smartphone, and then using that data, he or she, the cardiologist, can provide verification of the heartbeat, and all of these data are basically transmitted through a server. So the data is safely conserved or safely saved within servers, so that whenever there's a problem with anyone's cell phones, that data is safely secured there. What's also interesting is that our researchers have also tried to work on ultrasonography fetal monitoring. This USG system is a tele-USG system. It's a complete system that has been developed with its main feature to detect body parts of the fetus to reduce the risk of death in pregnancy by monitoring the growth rate of that fetus. So it does basically three things, right? It's doing fetal organ segmentation. It does fetal organ approximation, and it also does a fetal biometric measurement. It's helpful because this USG self-monitoring device can be used by patients in the house or everywhere, where they can basically take the vital signs and electrocardiography surveys tailored to the USG self-monitoring device. And then the data is transmitted through an infrastructure, and with a special algorithm, the server can process clinical data into information, managed with two-directional data communication with electronic health records. The data can all then be sent to nurses with clinical softwares that can allow them to provide recommendation for early interventions for patients who would need them. And the data can also be transferred to doctors who, from any place, from the hospital or from any other location, can annotate the data and can provide discussion where necessary and provide a recommendation for an intervention whenever necessary. So this is basically something that is allowed by the use case of artificial intelligence. That ultrasound image can then be segmented to basically understand the fetal organs, and then through a fetal curve approximation, then the size of the baby and the growth of the baby can basically be predicted, and the biometric, the vital indications of the baby's health can then be measured, and the data can be stored through a web service within the database within the server. So it works pretty much like this. A doctor or a nurse can basically be in a separate clinics. Someone can basically help patients who are coming to a clinic without a doctor, but has someone who is capable of operating the ultrasonography machine, right? So that person can basically assist the patient to provide diagnostics, and then that data can be stored in the cell phone, and that data through a very secure system can be transferred into the system so that the doctor in another location can assess that data. And although that doctor is not physically where the patient is located, that doctor can basically provide analysis, verify what has been segmented by the artificial intelligence system, and basically that doctor can provide a recommendation. Now, in Indonesia, where doctors and especially obgyn doctors is very scarce, this is very important that patients can basically meet doctors where they're not located within the same location, and it's done through very easily through cell phones. It's interesting because this research involves a very big consortia. It involves, within Universitas Indonesia, the Faculty of Medicine, Faculty of Computer Science, and within Indonesia itself, it involves funding from the Ministry of Information Science and Information Technology. It involves corporations. For example, in this case, PT Solusi 247 and Samsung Research and Development Institute. It's interesting because to a certain extent, this product has reached technology readiness level 9, which means that our researchers have built quite a reliable product to be used in the market. Not only a prototype that has been copyrighted, but a very reliable product that is ready to be released into the market. In addition to scientific articles and books that has been released on this particular use case as well. So another interesting use case is use cases in urban planning or urban management, where our researchers, particularly where I'm involved in this, is doing artificial intelligence for the purpose of innovative mapping and surveillance. So researchers sometimes have difficulties in updating data and doing capacity upgrades on urban spatial data. So in this case, our researchers use LiDAR-based data and analyze them using the help of artificial intelligence technology to basically measure building sizes in very dense urban areas. It's necessary because this is much, much easier than doing a survey, dispatching surveyors, which is very costly in very dense urban areas. And then our researchers could integrate and synchronize that data with the available urban spatial data from providers like the Geospatial Information Agency, our Land Registration Agency, Urban Planning Policy Agency, and so on and so forth, to basically upgrade our information systems to provide a basis for surveillance and monitoring purposes. Right, so our researchers can basically develop a system that helps urban managers and urban planners to monitor property taxation, or, for example, monitor building permit violations. And how they do that is basically by combining survey data, spatial data, the data that is provided by spatial planning agencies, Geospatial Information Agency, the Ministry of Agraria and Spatial Planning, and so on and so forth. And also, on top of that, add tabular data that is only provided at the city or county levels, and basically juxtapose everything to create a three-dimensional cadastral information. And then, with the help of artificial intelligence, build an information system that is capable of identifying urban building permit violations, property tax evasions, and so on and so forth. So how exactly are they using artificial intelligence for this purpose, right? So we have LiDAR data, which is basically like a radar data that provides a three-dimensional kind of image of the city. And we use that for two-dimensional and three-dimensional artificial intelligence analysis, right? The AI is used to provide two-dimensional building segmentation to basically separate one building from another, and land parcel identification, which basically helps us understand how the actual map works and is adjusted to the LiDAR data. And then, three-dimensionally, artificial intelligence help us understand and identify buildings and basically help us understand the actual size of each buildings. And with that, that helps us to understand by comparing the data that we have from the LiDAR, which has been analyzed through artificial intelligence, and compare that with the data that is owned by the local government to identify buildings that have been built beyond what has been permitted in their building permits, for example. So these are some of the examples of the use cases of artificial intelligence in research at Universitas Indonesia. I hope this gives a glimpse of how advanced our research is in the fields of artificial intelligence. I would be more than happy to answer questions and to communicate with you if you're interested, and to connect you with the appropriate people here at Universitas Indonesia if you're interested to work together with our researchers, particularly for the use of artificial intelligence in other fields. Thank you very much for your attention. Good afternoon.
Thank you, Mas Dr. Gamal. Okay, for detail about the AI and the algorithm, maybe Dr. Aryo will continue about how to implement, especially in the surveillance implementation in urban area system. Okay, please go ahead, Dr. Aryo. Time is yours.
Okay, good afternoon, ladies and gentlemen. Thank you for your opportunity. My name is Aryo. I am the representative of Mr. Gamal team. First of all, I want to send greeting from Mr. Gamal. He said sorry for not being able to accompany this live event. And in this opportunity, I would like to focus Mr. Gamal presentation on the usage of artificial intelligence in smart land surveillance systems. And now I want to share my screen first. Okay. Prof. Vishnu, can you see my screen?
Yes, perfect, Mas Dr. Aryo.
Okay. Today, I would like to focus our presentation on the usage of artificial intelligence on SLSS, which is Smart Land Surveillance System, an urban big data lidar information system approach. The system is led by Mr. Ahmad Gamal. And now, this is the outline of our presentation. First, we would like to explain about the existing condition of problem that we want to solve. Then we continue about the main issue that we need to solve the problem with our innovation. And our innovation comes from the usage of artificial intelligence, which we build some framework, and the framework will be the framework is built to enhance our promotion in solving the existing problem. And in the last session, we will try to state the progress and the challenge that we face in solving the problem. And here's the existing condition of our focus problem. First, we know that TBB or tax of building in Indonesia and BPHTB has the big potential to increase the revenue of government. Especially in rapid city development, there are a lot of tax potential that we can gather from people, because there are a lot of buildings have developed in our country. But the problem is there is no effective way to measure the development of building and store that is developed in urban area. And now, urban development is not according to plan. This is one of the main issues that we face, because sometimes the house or the building is built in a restricted area that we should not build. This is the main problem that we want to solve in our research. And this is the example of our problem. In Situ Rawa Besar, one of the region in Depok here, they are actually here in the green line. There should be no building here. But in fact, in reality, there are a lot of buildings have been built here by people, and this should be a green zone, which is this is the reserve area, which should be left natural. But because there are a lot of buildings here, there are a lot of people that violate the government rule. And we want to analyze, which is how we measure the main problem here by using some LiDAR data using drone. And we need to calculate and to detect how many violations that have been occurred in this area. And this is the other issue. Instead, beside the illegal construction, we also noticed that there are a lot of people that have different data which is registered in Indonesia government official here. For example, this house in Sismiop data, it only has property area which is 74. Luas bangunan, or we can say building measurement is only 74 square meter. But when we see this building in using our technology, which is drone here with LiDAR, we know that there are some difference between the registered data and the actual data. So if we calculate this using the factor of income, which is the tax, we know that there are a lot of excess building happens in urban area. So we need to measure the real square meter or the real measurement of this building to increase the government tax. And this is the other example of what we found in our research. You can see here there are green, red line and yellow line here. Usually, actually, this is the not appropriate data that has been registered in government, and this is what we found in reality. So there are a lot of tax parcel delineation that happens, that occur in real life, that we need to gather the data in order to maintain the real income for the government. And this is the outline of smart town surveillance system that we want to build. The first one is we need to update the data we gather from our system. Then we need to compare it with the data registered in government official. And we use the data mapping technology by using LiDAR drone technology. And the second step we want to conduct is we want to integrate and sync the urban big data that we gather with the government data. And the last one is we need to develop the system that integrate one another to automatically calculate the registered data of official and the real data of people that build some house in urban area. And the information system that we want to develop contains data that we have analyzed using our proposed artificial intelligence. And here is the main business process that we conduct. First, we get the spatial data, semi-automation using LiDAR. Then we upload the data to server. Then use some algorithm to conduct a measurement about to calculate the square meter of a building. Then we calculate the tax that someone needs to pay to government according to their house area. And the innovation that we have conduct in our research is like this. First, we take the photo of our survey data, then we calculate the spatial data using collaborate with tabular data. Then we build some cadastral information to enhance the information that government or other people or public to know the information of specific building in real life. This is the sample of our innovation. And how to build the model? First, we take the picture of the data, then we calculate the 2-dimensional or 3-dimensional data. Then we measure using our algorithm to measure the real measurement of a building. How we do this? The first method that we need, first we calculate the point cloud from a raw data, then we labeling the class, which is a building, vegetation, or road. Then we use some deep learning method to segment some area. We can see here there are a red dot, green dot, and blue dot. This is according to the class labeling that we have conduct. After labeling the class here, we want to segment the object we detect, and we want to visualize it in 3-dimensional data that can be retrieved by any users in our system. This is the 3D result of our system. And the progress that we have done so far is like this. First, we modified the DGCNN with Mahalanobis distance. And here the data set that we use, the average accuracy of our system, you can see here 75%, which is better than other methods that currently available for segmenting an area. And this is the visual evaluation of our data. Here you can see that this is the ground truth that actually should we retrieve from the system. And this is our method. Here you can see that the automatic building modeling here, it has accuracy about 72.79%. And here's the real color of actual area that we want to model. Here you can see that our method currently better than PointMap or DGCNR. And this is the automatic building modeling using semantic segmentation. This is the ground truth. We use 4, 5, until 9 layer to know how good our system is. According to our research and according to our analysis, we know that the more layer that we use sometimes make the result is better, but sometimes it decrease the accuracy. You can see here from 60 to 58, 60, 62, and so on. And we conclude that the best layer that we can use to modeling an area is 9 layer, which is 94.2. And the next one that we want to explore about our research is about spatial adjustment. This method is adjustment that we conduct to make violation between the actual data or orthophoto with PBB data or text data, how to make them synchron, or which means that there is no violation between the actual data and registered data. So we need to do some spatial adjustment between the data that we retrieve and the data that is registered in official government. And this is for example that we have analyzed an area in Pondok Cina region. You can see that here actually we have calculated some example about calculation of potential increase in tax payment. According to our calculation, we can conclude that actually there are a lot of income that government can gather from the tax. It's about 77 billion rupiahs because people here not registered their actual building data. If we use the LIDAR system to calculate the real area that people have about their building, we can increase the government tax only on Pondok Cina region about 77 billion rupiahs. Okay, this is the sample of our prototype system. You can see this is the interface. If we click some building here, we can gather some detailed information about the building from the year of the building built and the owner and the position of a building. You can see here like this. Okay, this is the closer look about our system. For example, we click some region here, and this is the building code in Indonesia here, and a lot of information can be gathered from our data. And the main challenge that we have faced still now is about how to increase the level of details information that we gather from our LiDAR system. You can see there are a lot of LOD here, level of detail, which means the first LOD is about how to know whether some area is a building or not, and the increased level of detail here, we know that we can see more detailed information about a building. For example, in LOD 3.1, we know which one is building, which one is the rooftop, and which one is the window. But in LOD 2, we only know whether some area is a building or not. And currently, we are still in LOD 2.1 and 2.0 state here. We target to increase our LOD configuration. And this is the currently system that we have, the current system we have. Here we can categorize which one is building, which one is area, which one is plantation here. Okay. And what we need to do to face the next challenge is about how to automatic building modeling some area with semantic segmentation point to polygon. Currently, we only know the point cloud or the point of a building, and the main challenge we need to face now is how to how to interpret the data from point cloud into a real building. This is our challenge that we need to face nowadays. And And currently, we have published some paper here. Here are some examples of paper for in Journal of Big Data and so on. You can see here. And we also have a patent that have been submitted to DGKI. And that's all about our presentation. And in short, what we have conducted is we built some information system to measure some area using a data ladder and artificial intelligence. Thank you very much for your attention. Back to the MC, Prof. Wisnu.
Thank you, Mas Dr. Gamal and Mas Dr. Aryo. Perfect and interesting presentation. Maybe because first presenter, Dr. Gamal, is explain about the result belong to Directorate DISTP. What the meaning of the ISTP? Directorate Sampel. And then some of the result is related with the AI. First one about the telemedical, and the second one about the surveillance system using LiDAR to build the smart city, for example. So maybe because we explain detail about the smart city surveillance system, maybe please give the answer related with the smart city. But it's okay when the audience will give some maybe question about related about the medical system. I think Mas Anwar also here, so that maybe we can discuss with the team. Okay, I will give a chance to the floor to give some question. Firstly, maybe I will request from the panelists, is any, because we have two type of attendee. First one about the panelists who can speak directly with the open mic, and the second type is participant who can give some question from the Q&A forum. Okay, if not, maybe I will ask some question. Is okay, Mas Dr. Aryo?
Yes, of course, Prof. Wisnu.
If you mentioned before, you use deep learning, DGCNN, and so on. And the first keynote speaker is Prof. Heru. He's also mentioned about the GPU and about the parallel computing and so on. In the point of view implementation, how about your algorithm? Maybe can you explain maybe about what kind of a computer do you use, and how long and how many data do you need to process your system? Okay, please, Dr. Aryo.
Okay, thank you, Prof. Wisnu, for the nice question. Okay, in general, we have a server in University of Indonesia that we use to train our algorithm how to measure the data that we have collect using LiDAR. And the data that we have gathered from the LiDAR, we use some DGCNN model that we have modified. And using the method, if you ask about how many data that we have gathered, actually, there are a lot of data that we have specialized to use in this system. But today, we currently focus our research on Pondok Cina. That's our main focus because this is the region that we know exactly and we can observe it in visually. Actually, there are a lot of many data that we have used. Maybe the details will be explained with in another session, but actually we train it about using some server that we have installed in University of Indonesia. So we don't use our main laptop to train our data, but we use some server that already installed in University of Indonesia.
Okay, thank you, Mas Dr. Aryo.
Yes.
Any question from the floor? Maybe because this is the last session, the audience is already tired because from this is the second day, but it's okay. One or two questions maybe from the audience. Okay. If not, can I continue? If some one or more
Yes,
questions?
of course, Professor.
Dr. Aryo?
Please, sir. That's okay.
Okay, because our conference is because you are in Keynote in ICACSIS. Even now we join together ICACSIS and IWBIS about the ICACSIS. We call about the algorithm. What is the challenging in the deep learning when we use, for example, for the 3D data implementation? Maybe is there any open problem or this is the first one? Okay, and the second one, because the audience is also from the military domain, because we have Unhan, also the cyber security. Is there any angle or any point so that maybe we can extend the collaboration among us? Among is the meaning is more than 2 parties. Okay. What is your opinion, Mas Dr. Aryo?
Okay, Professor, I would like to share first in order to answer your question. I want to share my screen. Wait a minute. Okay. As you asked before about the challenge that we have faced until today is about how this is the main challenge that we face. When we use LiDAR data to gather information, we only gather the point cloud from an area. Point cloud is about the point of an object that we have sensed using our LiDAR data. And the problem is how to interpret this system or this point into an object. For example, you can see here, according to this data, there are some red points and blue points, and the challenge is how to change the red points here to become this object, this rooftop. And this is the main challenge because as you can see in the previous slide here, it is difficult for us to detect whether an object is building with some door like this maybe. We cannot, currently we are still have difficulties to differentiate whether a point is part of a house or it is a different part of the house. For example, in urban area, the gap between one house and another house is very near. So it's very hard for us to interpret whether there are two buildings in our LiDAR data or there is only one building. Okay, that is the main challenge that we have to face because in training, the labeling is sometimes another difficulties that we have faced because when we want to find the ground truth of data, sometimes the ground truth is not asynchronous between data in government or in our partner that gather the data using LiDAR. So sometimes we need manually adjust the data, the coordinate of our data and the coordinate data that is retrieved, that is registered in official governments. This is for the first question. And for the second question about how to use our research for defense perspective, sometimes the LiDAR data can gather some point cloud, and this data can be used to maybe sometimes to make overview from an area, from a known area, to understand the circumstance of an area. Maybe for when we go to some war, and we can use our artificial intelligence combined with some drone. And when the drone fly into an unknown area, the drone can interpret what kind of objects located in the area, whether it is some vegetation, or maybe some building, or maybe some hut. We can now understand that using our LiDAR data. So from the military perspective, our research can be extended to observe some unknown data using artificial intelligence, and from the collected data, we can interpret it, and we can analyze to make some military strategy in order to make a good strategy to maybe sometimes to fight some people that is endanger our security. Maybe that's all my explanation, Prof. Wisnu.
Okay, thank you, Mas Dr. Aryo. We still have 5 minutes before closing ceremony. For the retired, maybe. From the okay, I just give some additional information. Dr. Aryo is also work in the drone with the Pak Rector of Unhan. So maybe we can extend in, as Mas Dr. Aryo mentioned, we can use a drone to sensing everything, because we use a LiDAR. LiDAR is three-dimensional data. So that maybe when, I don't know, in the military point of view, maybe sometimes we need more detail about the location, about the condition, and so on. Maybe I think this is also the interesting topic. Okay, if there is no question, maybe can you give closing statement, Mas Dr. Aryo, related with the, actually we got the grant from the, I don't know, before the Menristek, but now Menristek is divided for the education, become Menristek, and for the research, for the industrial research, joined to the BRIN as the first day opening session, opening plenary speaker from the chief of the BRIN, but because the chief of the BRIN, Pak Dr. Laksana Trihandoko, have some urgent, maybe Pak President or have some request to maybe to discuss with him. So maybe the plenary delivery by Dr. Panidito. I think it's quite good when we can join force to make the collaboration among us. We call a pentahelix, industrial, educational partner, and also the government, also the community, also the what they call, the last one is media. The last one is media. What is your opinion, Mas Dr. Aryo? Also the closing statement, and then maybe we will close the session. Please, 1 or 2 minutes.
Thank you, Prof. Wisnu. Maybe for the audience, I would like to tell you that Mr. Wisnu is my promoter when I was studied doctoral degree in University of Indonesia. And I want to say thank you for his guidance, because of his knowledge. I know a lot of things about perspective of artificial intelligence usage in cybersecurity, in military, and even in surveillance. And for the closing statement that Mr. Wisnu asked about this session is, I want to highlight that artificial intelligence is really a good tool that we can use in many aspects of our life, maybe for surveillance or maybe for LiDAR data, for military, or for other many aspects. So for a conclusion, I would like to highlight that if we want to increase the quality of our nation, artificial intelligence is one of the aspects that we need to focus, or we need to emphasize in order to increase the development of our nation. Maybe that's all, Ms. Professional, for the closing statement.
Okay, thank you, Mas Dr. Aryo. Please give applause to Mas Dr. Aryo and also Mas Dr. Gamal for the very interesting and very excellent presentation. And before we close and before I return back to the moderator, maybe because this is the last session of the ICACSIS, but we still have maybe only 20 minutes. Maybe the moderator will give some information about the closing ceremony. We will give some information about the award, who become a best presentation award, who become a best student paper award, or who become a best paper award. Okay, I will return back to Mas Moderator, Mas MC, Mas Lintang. Thank you.
Okay, thank you very much, Bapak Prof. Wisnu, Bapak Dr. Aryo, and Bapak Dr. Gamal for the interesting keynote speech session this afternoon. Okay, maybe let us present a certificate of appreciation for Bapak Dr. Gamal. So please host show the certificate. Okay, and then please allow us also to give a certificate of appreciation to Bapak Dr. Aryo. We thank you for your participation in this amazing keynote speech session. And then to conclude this session, please allow us to take a picture together. So for the panelists, please, maybe you can turn on your camera so that we can take a photo together. Okay. And please allow me to count to 3 to take the photo for this last keynote session today. Okay, I will count to 3. 1, 2, 3, smiles. Okay, thank you very much, ladies and gentlemen. Maybe just a bit info regarding the closing ceremony today. We will move to the room 1. So all participants can access the closing ceremony, which will be held after this session in room 1. And the link is available in the authors and participants guide. Okay, maybe that's all for this session. Maybe we can conclude the session. Thank you very much and good afternoon, everyone. Thank you very much.
Okay, just additional information. In room 1, it still have some presentation, but maybe we can join directly, even still have some presentation. But we will start the closing ceremony in 5:30 maybe. Okay. See you again in the room 1, everyone. Thank you.
Thank you very much.
See you again.
Thank you very much.
Recording stopped.